Hello everyone, my name is Jaden Fausto, and in this video we're diving into one of the most useful concepts in game AI, finite state machines. These are incredibly powerful tools for managing game logic, especially when it comes to character and enemy behavior. Whether it's an enemy patrolling and chasing the player, an NPC following a conversation tree, or a UI changing based on user input, finite state machines are making it all work. Today, we'll learn how to implement one in JavaScript. So what exactly is a finite state machine? Well, a finite state machine is a mathematical model of computation. It is an abstract machine that can be in exactly one of a finite number of states at any given time. In other words, a finite state machine is like a flowchart for decision making in a program or system. It has a set number of states and transitions with rules for switching between those states. Like this turnstile here, which has different states of locked and unlocked and different triggers on when it can transition between those states. A more common one is going to be traffic lights, though. Traffic lights have three different states, red, yellow, and green, and they will transition between each other based off of a bunch of different variables, such as walk buttons being pressed, or sensors being pressed from cars, or timers going off, and things like that. So let's go ahead and dive into how we can actually implement one of these. I'm going to be starting off with a empty game engine forked from this GitHub repository. And we're going to start off with this. I've added some stuff already. Mainly, I've added the basic programs that are the basic JavaScript files that we'll be using. I've created a simple player class that allows you to move around using WASD, and a basic enemy class that will just continuously follow the player around. I've created two other files. They're empty for now. They're going to be the FSM, or finite state machine.js, and enemy FSM, which is where we'll be implementing it. And finally, I've implemented all of these into the index.html and main.js so that it can actually hold the objects and start running. So just to show you what it looks like as of right now, it's just a red enemy following your character, which you can move around. Super simple for now, and I'd like to keep it that way. So if we go ahead and go to our code, we can start implementing a finite state machine. So I'll go ahead and start creating this class. We'll go ahead and call it finite state machine. And in a finite state machine, there are two main variables that we'll want to hold. First, we're going to want to be able to hold our current state, and we're going to want to be able to hold the available states. And in our constructor, we'll go ahead and pass in an initial state and just set all of our things. And we'll go ahead and map this. And that way we'll be able to create a map of all the different states. We're going to have it be basically an enumerator mapping the names to a string. After that, there are a few things that a finite state machine needs. Namely, it's going to be able to want to add different states to its available states. In this, we're going to be passing the state name we want to add, as well as a handler. That's just the function that we're going to want to run, which we'll implement in the actual enemy class. We're going to want to be able to change between states. And then, since this is an object, we're going to go ahead and have an update method. And since I use private methods, we're going to get a get state. So I've implemented that already. Super easy for the get state. So let's start implementing the other methods. For add state, this one's super easy. We're just going to go ahead and access our available states, and we're just going to set state and handler to that. And that's it for that. Super, super simple. I'm just adding the documentation just to make it easier for later. And then for change state, this is where we're just going to do some quick error checking and then changing the states between. Just setting our current state to the new one. So we're going to first check if it has the new state in our map. Keep mistyping that. If it does, we're going to go ahead and set our current state to the new state. And we can return from this function, or we don't actually have to return from this function. And then else, that means we're going to run into an error because our state map doesn't actually have what we're trying to change to. So we'll just go ahead and send an error saying that we have an invalid state transition. And believe it or not, that is all for that. Still very simple. And finally, in the update method, we're just going to go ahead and access our handler for the different state that we're in. So because our handler is saved to a map based off of our state, we can access it with our current state. And if this handler does exist, we can call that function that we're passing in. And that's going to be in our entire finite state machine class. We're just going to add states that are available, and we're going to be able to change between them. So now we can go ahead and start creating our enemy. So we can create a class called enemy FSM to differentiate it from the other one. It's already differentiated if we just call it enemy, but we'll do it like this for now. And before we actually start it, I'm going to go ahead and create an enum for it called enemy state. This is going to be all the states that our enemy can have. So thinking about it, what states do we actually want our enemy to be able to have? Well, first, we definitely want our enemy to be able to have an idle state. And it's kind of boring if our enemy just stands there doing nothing, so we want it to be able to wander around every once in a while. Then, we want it to be able to chase the player if the player gets too close. And if it gets close enough to the player, we want it to be able to attack. And this is just a very basic 4 different states for us to implement. So now going to our enemy class, there's a few different things that we want it to be able to have. First, we want to be able to store the position of our enemy. We want to, if we can, we'll store the width and height of it, its movement speed. Then we want to actually have it have an FSM object, be able to manage its states. It's basically a manager. And then just for later, I'll create this wander timer and the wander direction, which will be used when implementing the wander state. And we'll just set this to a vector for now. Call it wander direction. Bam. And then I'll create my constructor for it. I'm gonna go ahead and pass in the x value, the y value, and then the width we can default it to 20. The height will default it to 20, and the speed, which will default to 2. And then after that, we can just assign all of those variables using the autofill. Super duper easy. Looks like I misspelled that width. This dot speed equals speed. And then here will actually is where we're gonna add the finite state machine to the enemy. This is gonna be super easy. We'll just go ahead and this dot fsm equals new finite state machine, and let's make the initial state enemy state dot idle. Then we're gonna go ahead and actually add all of the states. This dot sem dot add state, and super easy. It's gonna be enemy state dot idle is what it's called, and then the function is just gonna be, we'll call them all in the same thing. It'll be handle idle state. Then we'll bind it to this. And then I can create little, I'll do the same thing for the other ones. And because it's giving us this error, I'll go ahead and create the skeletons of those real quick. So we'll want to be able to handle idle state, handle chase state, handle wander state, and handle our attack state. Bam. So here, double comment for us, create XM, and define our states. Next, for our update function method, all we'll do in here is we'll just update our finite state machine, since that's basically going to control everything that's happening. And that's it there. And now we can actually start defining our states. I've separated like this because it makes it very easy. All that's going to be happening is within each of these, we'll handle whatever the state is doing, and in them we'll also put the transitions. So, for example, with the idle state, we're going to go ahead and access the player location. We need to do this to be able to detect when it needs to change states, which I'll implement actually this since I'll be using it again later in a helper method called calculate player position. And in this, we're just going to go ahead and get the player by calling our global variable game engine, grabbing its entities, and we'll find the entity that is an instance of player. Find. And that should be equals. And looks like that it's not giving me any errors. And then if the player doesn't exist, we can return a empty vector. That way, what it'll just do is if the player doesn't exist, it'll just keep going to the location 0, 0, I believe. Or stay still. Oh, calculate. Yeah, it'll stay still. So, bam. And then, if the player does exist, we can grab the change in direction for the x. X equals player.x minus this dot x. Same for the y, this change in the y. And we could just return that as a vector with the distance. let's calculate distance equals, it's going to be math dot getting the hypotenuse between dx and dy. You could also do with math dot square root of dx times dx plus dx times dy. Same thing. And now that we're able to calculate the position of the player relative to the enemy, we can now use this helper method here, calculate player position, and then for idle state, we'll mostly just want it to stay still and do nothing, which means we don't actually need any code. So now we'll just do the transitions, because if it's idle, it's not doing anything. So transitions. The first transition is if the player location dot distance is less than whatever our detection radius is going to be. So we can create some static variables here just to keep our code clean. Detection radius, let's make it 150, and also throw in all of the other ones that we'll need later on, like chase loss radius equals 200. Let's go. Our attack radius equals 50. Our wander time minimum is going to be 150, and our wander time maximum is going to be 250. Those are all going to be the constants that we'll need. So now we can use that enemy.detection radius. So if it's within that detection radius, enemy FSM.detection radius, and that should be called player location. Then we'll just change the state of our finite state machine. So finite state machine dot change state, and we'll pass it enemy state dot chase, because we want it to chase the player if it's in the detection range. Else, we don't want our guy to just be idle, so we want to be able to wander around every once in a while, so it changes position a little bit. So we'll just implement this using random. You could implement this however you'd like. You could make it go in a square or a circle motion, but we'll just go in a random. And then we'll change the state to wander. And it's going to be the same way, enemy state dot wander. And that is it for our handle idle state. All that's happening is we're not going to do anything, and it'll transition if it meets any of these requirements. So now we can go ahead and actually implement the chase state here. And again, we're going to need access to that player location, just like that. And then first things first is if the player ends up running away, since we go to the player, their speed is 5 and our enemy's speed is going to be 2, then we want to be able to disengage and return back to an idle state. So if our player location is dot distance is greater than our chase loss radius, then this dot finite state machine dot change state back to enemy state dot idle. After that, while we're in the chase state, there's two other things that can happen there. One, either we're within our attack radius, meaning we want to attack the player, meaning we'll change to the attack state, or we're not, which means we're going to want to actually chase, and that just means moving towards the player. So we can check if our player location dot distance is less than our attack radius, enemy state dot attack, enemy FSM dot attack radius less than it, then we can change our state to attack. And then finally, what we can do is, this means that no transitions happen. We can continue or run our chase state. And in this, all we want to do is just check if our player location is greater than our attack radius, which we know it is, greater than or equal to, I guess, less than or equal to attack radius. There. Greater than attack radius, then we just want to move our location towards the player. So all we have to do there is we have to grab the player location dot dx, which we're grabbing here. This is just our change in x relative to the player divided by their distance, player location dot distance, and we can multiply all of this by our speed dot speed, and then same for the y. And that's it. That's our whole chase state. After that, we'll implement our wander state. In wander state, we just wanted to move semi-randomly. So once again, we're going to want access to the player location to be able to change state later. If our player location, it's going to be the same code as in the idle. Dot distance is less than our enemy detection radius. We'll change the state to chase. Bam. I actually don't think we need the return here, but it's okay. Then, here, I don't believe that there's any other time we care, so we'll start implementing all of our stuff. I'm going to copy and paste this time since it's a lot of weird typing with letters I don't like. And then basically what we're doing here is we're just checking if that wander timer that we set up here is less than or equal to 0. If it is, we're going to go ahead and get a small random amount of time and set it to that. And we're going to create a random direction that we're going to start moving towards. And then as long as that timer is running, we're going to keep moving towards that direction. And then once it hits 0 for the timer, we'll change back to the idle state. This will basically just make the enemy move in a random direction every once in a while, so it doesn't just stay still. Finally, for the attack state, this one, you'll just implement whatever attacking you're doing. So for now, we'll just do a print statement, and then, of course, once we're done attacking, we'll want to change the state back to chase. Finally, we're gonna just be able to want our draw method so we can actually see our enemy. I just copied and pasted there. Here, this is just gonna go ahead and display our current state. this is going to display our enemy. And this here is just a little debugging one just to show and display our, this is going to display our detection radius. And then it looks like I have a little helper method there just to even more show the difference between the states. I have different colors for each state that the enemy changes to. Bam. And then at the very bottom, I'll just have all of my getters for whichever variables are important. So our location and our current state. And that's going to be it. We've implemented the entire finite state machine. And we're good to let this run. Let me go ahead and change main first. So instead of enemy basic, we're going to create an enemy finite state machine. And if I go ahead and hit play, you can see our enemy is currently in idle. And they'll change to wander every once in a while, start moving in a random direction, go idle again. And then if we do go into their detection radius, they'll start chasing us. They'll go back to idle if they get close enough. You could see there is kind of glitching between attack and chase. That's just because I don't have an attack timer, which is something you can implement on your own. But once I get out of the radius, I'll go back to idle and wander around every once in a while. That's it. And the way that I've made this is very reusable. So all you have to do is do something like, for example, you want to create an NPC. You just have to be able to create your class, and in your constructor, it's the same thing. You're going to create an finite state machine with the initial state, and you'll add all the different states you need. Handler here, and same thing as before. Super duper easy. Hope this video was helpful, and hopefully you can expand it to make your games a lot cleaner in their code, a lot more organized and easy to understand. Thank you. Have a good one.